All right, experiment number 1. So I have a little bowl of water, got my paper clip, and I have my fork. Just gonna use the fork just to kind of help place the paper clip on top of the water. Let's see what happens. All right, so the explanation to this first experiment. We have our bowl of water and our paper clip. So in actuality, our paper clip is denser than our water, so it should sink. If I put the paper clip in normally, it's just going to sink down to the bottom of my bowl. I know it's kind of hard for you guys to see on here. The way that I put the paper clip in initially is I did it in a way that I'm not breaking the surface tension of our water. So we know that our water has that unique property of very, very high surface tension because of the hydrogen bonding between our water molecules. So our water molecules are attracted to each other. They're pulling each other together. So if I'm not able to break that surface tension, my paper clip is able to sit right on the top and not sink, even though it is denser than the surrounding water. If any of you have been to the lake in the summertime, you see those little we always call them water skaters, or the water gliders, I guess. The little bugs that glide on the top of the water. This is exactly how they do that as well. What they're doing is they're lightly distributing their weight across a large surface area so that they do not break the surface tension of the water, and then they're able to skate across the water. Ok, experiência 2. Eu tenho a minha tigela de água aqui. Tenho minha sabão aqui. E meu pimento preto. E vamos ver. Então eu vou pôr esse pimento preto aqui na tigela de água. Bom. E vamos. So we've got our black pepper in the bowl of water. I'm going to put some Dawn dishwashing detergent on my finger. Let's see what happens. So the explanation for experiment number 2, what's happening here is I have my pepper flakes that are floating on top of the water. Our pepper, oops. So explanation for experiment number 2, I have my pepper flakes that are floating on top of the water, and I end up putting Dawn dishwashing detergent on my finger. So what dishwashing detergent or other detergents are, they're considered a surfactant. And so what a surfactant does, it actually lowers the surface tension of our water. So when our surfactant comes into contact with our water, at that point, it's lowering the surface tension in that area, but our water still wants to retain its surface tension. So what it's going to do is it's going to spread away from that particular our detergent. So the area where we have our detergent, our water is going to want to pull away from it. So as it's pulling away, it pulls the pepper flakes along with it, and that's why we see our pepper flakes kind of scatter or fugir is the Portuguese word, but run away from the Dawn dishwashing detergent. Okay, so experiment number 3. I know you guys didn't do this experiment, but I found it pretty interesting. What it's called is called the Cartesian diver. So I have a 2-liter bottle filled with water. What I made was a little device. This is going to be my Cartesian diver. You can also use a ketchup packet. So I'll show you first with the device that I made, and then I'll show you with my ketchup packet. So I'm going to put this in here, and I'm going to demonstrate for you guys. Close the lid on it. So as you can see here, my little device, my Cartesian diver, is floating on the top of the water. I'm going to make it so that my Cartesian diver sinks. So what I'm going to do is I squeeze the bottle, and now my diver sinks. And then I release, and it comes back up. So I can even control, I'll slowly squeeze it so it starts to go down. And then I can even hold it right there in the middle. Or go all the way down to the bottom. Bring him right back up to the middle. and then back up to the top. So all that depends on how much pressure I'm putting on the bottle. So the more pressure I put on the bottle, the more it sinks. The less pressure, the more it floats. So again, I can do the same experiment. This time I'm just using a little Juicy Juice bottle, just because the opening is a little bit bigger and I can get my ketchup packet in there easier. So when I open this up and I put my ketchup packet in, what we'll see is that the ketchup packet floats. So then I close it again, and I can do the same thing. I'll end up just pushing, it sinks, I can release it, and it'll float. So if you guys want to, you can try that at home. All you need is either a 2-liter bottle like this one, Juicy Juice bottle like this one, packet of ketchup, and then I'll tell you how I made my little Cartesian diver here if you would like to try it out at home. So in order to understand how this experiment works, we need to understand a few different concepts. For anything to float in water, for an object to float in water, the average density of our object needs to be less than the density of water. If the average density of our object is less than the density of water, it's going to float. In order for an object to sink in our water, the average density of that particular object needs to be greater than the density of our water. This will allow our object to, or this will cause our object to sink in water because of the greater density. So a liquid, when we're talking about a liquid has very little compressibility. When I apply a great amount of pressure to this liquid, the volume of that liquid is going to remain, we can say that the volume of the liquid remains the same. It's going to be relatively the same, much more so than a gas. So again, our liquid is not compressible. A gas, on the other hand, is compressible. When we put a gas under higher and higher pressure, that gas is able to compress and it's going to take up a smaller volume. This is Boyle's law. So at higher pressures, our gas takes up a smaller volume. So if we have the same amount of gas, we put it under pressure, it's going to compress, and that same amount of gas is going to take up a smaller volume, and therefore the density of that gas is going to increase. So how these concepts come into play with our Cartesian diver, there are two different ways that we end up showing this. With our straw, what ends up happening is the bottom of my straw is open. So when I put this in the water, there's a certain amount of gas or a certain amount of air that's inside my straw. As I increase the pressure, so when I'm pushing on my bottle, my 2-liter bottle of water, I'm increasing the pressure that is on the gas, or increasing the pressure on the gas inside of my straw. So that's going to do is it's going to compress the gas inside my straw, and my gas is going to end up taking up less space. So it's going to have a lower volume. Because the bottom of my straw is open, what that's going to do is it's going to draw water up into my straw. Because water is denser than the air inside, or denser than air, that's going to increase the total or the average density of my little contraption here, so of my Cartesian diver. So as I compress that gas, it takes up less volume. Water is going to be pulled up into my straw, and it's going to increase the average density of my Cartesian diver. With increased density, it's going to cause my Cartesian diver to sink. When I release that pressure, my gas expands, so it takes up more volume, and it pushes that water out. My gas is less dense than my water, so it decreases the density or the average density of my Cartesian diver, and it causes my Cartesian diver to then float again because it is now less dense than our water. This is the same thing that's happening with our ketchup packet. Inside our ketchup packet, we have ketchup, obviously, and so it's around the same density as water, a little bit denser than water. But we do have a little bit of air that's inside of this ketchup packet. So that's what allows the ketchup packet to normally float when we put it into water. However, same thing that's happening when I put more pressure onto my water, it's applying more pressure on that gas inside or that air inside of our ketchup packet. That air is going to contract or condense, take up a smaller volume, still has the same mass. So the same mass at a smaller volume is going to have higher density. So it caused our ketchup packet to sink. Once I release that pressure, that air is going to expand again, so we have the same mass at a larger volume, so that's going to be lower density, and so our ketchup packet is going to float back to the top. So if you guys are interested in trying this at home to make a Cartesian diver, all you need is a packet of ketchup, to be honest. Ketchup works best. I tried a couple other things like hot sauce from Taco Bell, soy sauce, other stuff, and I found that ketchup is what actually works best. So you can either use ketchup packet, drop it into a large bottle of water. It doesn't work very well with our normal sized bottles of water. So a container that's about 2 liters is gonna be pretty good. Just drop it inside, and then what you do is you're gonna squeeze on it to increase the pressure, release it to decrease it. When you squeeze, it sinks. When you release the pressure, it floats. If you want to make a Cartesian diver, like this one, all I did is I took a straw, I ended up cutting it, and then I used nickels just to hold it and compress it so that I could end up burning the one end to close up the one end. But I just leave a little bit of space on the end here, right? And then I end up burning it. So the reason we do that is just to close that up. All right, so make sure that it's sealed. As you can see, sealed up. When I release that, this end is now sealed and the other end is still open. So then what I ended up doing is I took a little safety pin. Be careful when you do this so that you don't stab yourself. I poked a little hole in the bottom here. So again, be careful that you don't stab yourself. Poked a little hole, and then I just took a paper clip and put the paper clip through the hole. Okay. And then you can play with it if it floats too much in your water, you can add paper clips to add more weight. So I can play with it, make sure that it's gonna work. So I have to squeeze quite a bit on that, so what I'll do is I'll add another paper clip to it just to increase the density on it, so that you don't have to squeeze as hard to get it to sink. So I add another paper clip, make sure that it still floats. There it goes. So it still floats, still floating at the top there. And now when I squeeze it, it's a lot easier. And it's not coming back up. Interesting. So there it goes. Okay. So you guys can play with that at home.